In this video, we're going to talk about volts, amps, and watts. So let's start with the volt. So what is the volt? The volt is basically a unit of voltage. And 1 volt is equal to 1 joule of electric potential energy per 1 coulomb of charge. And so it's the ratio of electric potential energy to electric charge. Now you need to understand the difference between voltage and electric potential. And to illustrate that, let's say if we have a resistor, let's call this point A and point B. Let's say point A is at 12 volts and B is at 4 volts. So the electric potential at B is 4 volts and the electric potential at A is 12 volts. But what is the voltage across this resistor between points A and B? The voltage is the difference in these 2 points. It's the electric potential difference of point A and point B. So it's going to be 8 volts. So both voltage and electric potential, they share the same unit, and that is volts. Now sometimes you might see voltage represented as millivolts, volts, or kilovolts. Now you need to know that 1 volt is equal to 1,000 millivolts, and 1 kilovolt represents 1,000 volts. So here's a question for you. How many volts is equivalent to 342 millivolts? So how can we convert millivolts to volts? If you want to convert millivolts to volts, you need to multiply, or rather actually, you need to divide by 1,000. And if you want to go from volts to millivolts, you need to multiply by 1,000. Now, here's how you can convert it. Start with what you're given. Now, we need to cancel this unit. We said that 1 volt is equal to 1,000 millivolts. So you need to set up this second fraction in such a way that the unit millivolts will cancel. And so it's going to be 342 divided by 1,000, which you can get that answer by moving the decimal point 3 units to the left. And so this is going to be 0.342 volts. So that's how you can convert millivolts into volts. Now here's another example. Let's say if we have 12 kilovolts. How can we convert that to volts? How many volts is 12 kilovolts? Now intuitively, we know that 1 kilovolt is 1,000 volts. So 12 kilovolts has to be 12 times 1,000. It's 12,000 volts. And so anytime you want to go from kilovolts to volts, multiply by 1,000. Now let's talk about batteries. A typical AA battery has a voltage of 1.5 volts. And perhaps you've seen the 9-volt batteries, which looks like this. And then you have the car batteries, which generate 12 volts. Let's say this is the positive terminal and this is the negative terminal. If the negative terminal is at 0, the positive terminal is at 12. The difference between these terminals is 12 volts. Now let's go back to this example where we had a resistor and we had 2 points, point A and point B. And we said point A was at 12 volts, point B was at 4 volts. So 8 volts is across the resistor. So what does that mean? Well, we know that 1 volt is equal to 1 joule per coulomb. So 8 volts represents 8 joules per coulomb. So this means that for every coulomb of charge that passes through this resistor, 8 joules of energy is transferred to the resistor. So let's say if we have 2 coulombs of charge flowing through the resistor, that means that 16 joules of energy will be absorbed by the resistor. And so voltage is the ratio of electric potential energy to charge. So the more charge that flows through this resistor, the more energy will be transferred through that resistor. So if we have 5 coulombs of charge flowing through it, then in that case, 40 joules of energy will be transferred to that resistor. Now let's talk about the amp. What is an amp? An amp is the unit of current. 1 amp is equal to 1 coulomb of electric charge that flows per second. So current, which is represented by the symbol I, is equal to charge divided by time. So it's the rate at which electric charge flows. So let's say if we have 5 amps of current, that means that 5 coulombs of charge is flowing past a given point every second. Now, in order to truly understand what an amp really represents, we need to know what a coulomb represents. Coulombs are the unit of electric charge, and 1 electron has a charge of 1.6 times 10 to the negative 19 coulombs, but negative 1.6. And so electric charge is directly related to the quantity of electrons or protons. It could be any type of charged particle depending on what is the charge carrier in the circuit. In this case, when dealing with metals, it's electrons. If you take 1 and divide it by this number, you're going to get this number, or this fact. Negative 1 coulomb represents 6.25 times 10 to the 18 electrons. And so when you think of a coulomb, it's a way to represent a large number of electrons. Now, for those of you who want to understand why 1 coulomb represents that many number of electrons, here's how you can show your work. So start with 1 coulomb. Let's use negative 1. And then convert it. We know the charge of 1 electron. 1 electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. And so when you set it up this way, you can see that the unit coulombs will cancel. And by the way, for a conversion factor, the only way this can work is if the numerator is equal to the denominator, which it is. And so if you take 1 and divide it by 1.6 times 10 to the negative 19, that's how you can get this number, 6.25 times 10 to the 18 electrons. So that equals negative 1 coulomb of charge. So now, an amp of current is 1 coulomb of charge that flows per second. So we could say that whenever you have 1 amp flowing in a circuit, 6.25 times 10 to the 18 electrons is flowing per second. And so this helps you to understand the concept of electric current and what an amp truly means. So 1 amp tells you how many electrons are flowing per second through any given point. Now let's talk about the units. So you might see current measured in amps, milliamps, or sometimes even microamps. You need to know that 1 amp is equal to 1,000 milliamps, and 1 milliamp is equal to 1,000 microamps. But usually, you're going to deal with this fact. And so keep this in mind. Just like we converted millivolts to volts, if you want to convert milliamps to amps, simply divide by 1,000. And if you want to convert amps to milliamps, multiply by 1,000. So let's say if we have 0.015 amps, what is the electric current in milliamps? So we know that 1 amp is equal to 1,000 milliamps. And so setting up this way, we can see that the unit amps will cancel. And so it's going to be 0.015 times 1,000. So we need to move the decimal point 3 units to the right. So this is going to equal 15 milliamps. And so that's how you can convert amps to milliamps. Consider this question. Let's say if we have a resistor and we have 4.3 times 10 to the 21 electrons flowing in this resistor in a period of 5 minutes. So every 5 minutes, 4.3 times 10 to the 21 electrons flows through this resistor. What is the electric current in the circuit measured in amps? How can we calculate the electric current in amps? feel free to try this problem. So recall that current is equal to charge divided by time. And so we need to find the charge in coulombs, and we need to get the time in seconds. So let's convert minutes to seconds. Now we know that there's 60 seconds per minute. And so 5 times 60 is 300. So the time, which I'm going to write it up here, is 300 seconds. Now let's get the charge. All we need to do is convert electrons to coulombs. So let's start with this number. So recall that we said that one electron has a charge of 1.6 times 10 to the negative 19 coulombs. Now, we really don't have to worry about the negative sign because the current that we're going to calculate, we're going to make it positive in the end. So let's not worry about this negative sign. 4.3 times 10 to the 21 multiplied by 1.6 times 10 to the negative 19. That will give us a charge of 688 coulombs. And we can see that the unit electrons will cancel. So now that we have the charge, we can now calculate the current. So keep in mind that this is Q. And so the electric current is going to be the amount of charge that flows per unit second. So it's going to be 688 coulombs, and we're going to divide that by 300 seconds. And so this is going to be 2.29 coulombs per second. And recall that 1 amp is 1 coulomb per second. So 2.29 coulombs per second really is 2.29 amps. Therefore, this is the current that flows in a circuit. And so hopefully this helps you to see the relationship between the current in amps with regard to the number of electrons that's flowing per unit time. So the current represents the rate at which electrons are flowing in a circuit. Now, let's talk about the watt. What is a watt? A watt is a unit of power. So this leads to another question: what is power? Power is the rate at which energy is transferred. Power is equal to energy over time. We know that the unit of energy is joules, and the standard unit of time is the second. So 1 watt represents the transfer of 1 joule of energy per second. So here is an example problem. Let's say if we have a battery. And so this battery is transferring energy, let's say, to a light bulb. Let's say this battery transfers 8,000 joules of energy every, let's say, 20 seconds. So how much watts is being applied here, so to speak? What's the rate at which energy is being transferred to this light bulb? So calculate the power in watts. The power is going to be the energy divided by the time. That is the energy that's transferred. So 8,000 joules of energy is transferred every 20 seconds. So what's 8,000 divided by 20? Well, we can cancel a 0, and so it becomes 800 divided by 2, which is 400. So it's 400 joules per second. And keep in mind that 1 joule per second is 1 watt. So we could say that it's 400 watts. So that's how much power is being delivered to this light bulb. So power tells you the rate at which energy is being transferred. So let's say if you decide to go to Walmart and buy a light bulb, let's say one of those bright light bulbs, a 100-watt light bulb. So what this means is that every second, 100 joules of electric energy is being absorbed by this light bulb. Now this light bulb will convert some of that energy into light and some of it into heat. But every second, this light bulb consumes 100 joules of energy. And so when you see watts, that's what it tells you. How many joules of energy is being consumed every second. So for instance, a 50-watt light bulb will only convert or absorbed 50 joules of electric energy every second. Now let's talk about the units. A kilowatt is equal to 1,000 watts. 1 watt is equal to 1,000 milliwatts. And sometimes you may see megawatts for like a very high power industrial applications. A megawatt is 1,000 kilowatts, which is 1 times 10 to the 6 watts. And so those are some units that you may want to keep in mind. Another equation that you need to deal with is this one. Power is equal to voltage times current. So we know that power is measured in watts, voltage is measured in volts, current is measured in amps. So we could also say that 1 watt is equal to 1 volt times 1 amp. That's another way in which you could describe the unit watt. Now let's work on some practice problems. A 12-volt battery is connected across a 50 ohm resistor. How much current flows in the circuit? So let's begin with a picture. So this is the symbol for a battery, and here is the resistor. So this is the positive terminal, and this is the negative terminal, and conventional current will flow from the positive terminal to the negative terminal. And we have a 50 ohm resistor. And the voltage is 12 volts. To calculate the current, we can use Ohm's law, V equals IR. So the voltage is 12, the resistance is 50, and to solve for I, we need to get it by itself, so we could divide both sides by 50. So therefore, it's going to be 12 divided by 50, which is 0.24. And so the current flowing in a circuit is 0.24 amps, which I'm going to write over here. Now let's move on to part B. How much power is absorbed by the resistor? A simple formula that we could use is P is equal to VI. The voltage across the resistor is the same as the voltage across the battery because the resistor is directly connected to the battery. And so we have 12 volts across the resistor and a current of 0.24 amps flowing through it. So it's going to be 12 times 0.24. So the power is 2.88 watts. And so that's it for part B. Now let's move on to part C. How many joules of energy will the resistor absorb after 8 minutes? How can we find that answer? Now recall that a watt is a joule per second. So 2.88 watts, we can write that as 2.88 joules. That's transferred to the resistor every second. Now let's convert seconds into minutes. So there's 60 seconds per minute. And so we have the power in joules per minute. So now we can multiply by the time, which is 8 minutes, and we can get the energy in joules only. And so now we can cancel the unit minutes, leaving us with the unit joules by itself. So it's going to be 2.88 times 60 times 8. And so this is going to be 1,382.4 joules. So after 8 minutes, the resistor will absorb 1,382.4 joules of energy. Now let's move on to number 2. An 18-volt laptop draws 350 milliamps of current from a power supply. What is the power rating of this laptop in watts? Feel free to pause the video if you want to try this problem. So in this problem, we could simply use this equation. P is equal to VI. We have the voltage, it's 18 volts. And we also have the current, which is 350 milliamps. However, we need to convert that to amps. So recall that 1 amp is equal to 1,000 milliamps. So to convert milliamps into amps, divide it by 1,000, or move the decimal 3 units to the left. So 350 divided by 1,000 is 0.35. So the current is 0.35 amps. So all we need to do now is multiply 18 by 0.35. And so the power consumed by this laptop is 6.3 watts. So every second, the laptop absorbs 6.3 joules of energy. Number 3, a 200 watt TV is connected to a 120 volt power supply. How much current in amps and milliamps does it draw from the power supply? So once again, we could use the same formula, P is equal to VI. So we have the power because the unit of power is the watt. And so the power is 200 watts. We also have the voltage. The unit of voltage is the volt. So V is 120. Now let's solve for the current. So we need to divide both sides by 120. 200 divided by 120 is 1.67. And so this is the current in amps. The watt divided by the volt will give you the unit in amps. Now we need to convert it to milliamps. We know that 1 amp is 1,000 milliamps. So 1.67 amps must be 1,670 milliamps. To set up the conversion, you can write it this way. So 1 amp is equal to 1,000 milliamps. And you can see the unit amps will cancel. So it's 1.67 times 1,000, and that will give you 1,670 milliamps. And so that's how much current the power supply delivers to the TV. And so that's it for this video. So we have the current in milliamps and in amps. Thanks for watching.